Okay, so welcome back once again. And in my previous lecture, I was talking about a statistical term, and I have loaded a tips data set. Mean, median, mode, skewness, IQR calculation we have already seen. Now let's try to understand that what is the meaning of a histogram, what is the meaning of a box plot, bar plot, pie chart, line chart, pair plot, heat map, and what it is going to tell you and what kind of information it is going to give it to you. So let's try to understand one by one. So first of all, I will be talking about a histogram over here. So let's try to draw a histogram. To draw a histogram, and I'll tell you that what histogram is going to tell you basically. So a PLT plot dot figure, and here so I'm going to give my figure size. So basically a canvas size in which it is going to plot each and everything. So let's suppose I'm going to give a figure size is equals to 10 cross 5. Yeah. So this is just going to reserve the entire figure. And then here, so SNS, SNS means the Seaborn which I have done as an import, I can try to call basically a hist plot. And I will be looking for a histogram plot for a total bills. Now, if I'm going to execute it, so this is the histogram plot which I am able to find out. Now, technically, what this histogram is going to talk about, let me tell you that part first, because majority of people gets confused there itself. So what my histogram is going to talk about. So see guys, histogram is a very simple plot. It is going to help you out even in terms of finding out the the shape of the data, or whether my data set is normal, whether my data set is skewed. Just by looking at the histogram, you will be able to find out. So if I'll talk about a x-axis, so this is my x-axis by the way, and this is my y-axis. Fine. So this is my x-axis, this is my y-axis. Now on x-axis, this particular one is going to talk about ranges of the data. And this y-axis, so x-axis basically talks about the data distribution between this to this range. I'll talk more about it. And this y-axis is going to talk about the occurrences of the data. Now, what it means, by the way. So, if I would like to answer to this question with another question, so let's suppose I'm trying to phrase my question in this way: that how many people have paid a bill maybe between $30 to $33. Let's suppose this is the 33. Let's suppose I'm just imagining. So how many people have paid bills between $30 to $33? These many people. Simple, right? So your y-axis is trying to represent that count. How many people have paid a bill between $20 to $23? Yeah. How many people have paid a bill between $20 to $23? So basically these many people have paid a bill between $20 to $23. How many people have paid actually bills between approximately $47 to $50? So these many people have actually paid a bill approximately between $47 to $50. In this way, you can try to understand this entire histogram. As simple as that. So this x-axis is going to talk about the distribution of the data, the range in which your data is fluctuating, and then your y-axis is trying to talk about the count inside that distribution, that how many people or how many terms, something like that, right? It is going to talk about. So hope you are able to get some sort of a sense out of it. Now, so here, if I'm going to connect all the tips approximately, you will be able to see a shape of your normal distribution curve. Yeah. And it looks like that my data set is skewed, and it's skewed in a positive direction, I believe. And I believe my skewness calculation was 1.21 or 1.1. I don't remember. I just have to check above. Right. So skewness was what? So my skewness was 1.12, right? Which was a positive one. And same thing I'm able to find out even with the help of this particular graph, that it's a positive right hand side, it's a skewed data, right? On a right hand side, my data set is skewed, right? My right hand side data set is skewed, means there are some people, right? There are some people, not many, but there are some people, maybe 5 people, you can say, so who have paid more bills, basically, right? Who have paid more bills over here. This is what it means. And same is getting reflected even over here. As simple as that. Yeah, as simple as that. So this is basically a histogram which is going to help you out in that sense. Now let me add a couple of more parameters so that I can try to refine this graph. So KDE, kernel density. So KDE is equals to true. If I'm going to call, so the graph which I have drawn manually, you will be able to see that system itself is trying to draw the graph. Yeah, system itself is trying to draw the graph. I can control a color as well. So color of the graph, maybe I'm giving red over here. So, okay, this entire graph becomes red, beautiful red, by the way. And bins means size I can try to control. So there is something called as bins, and let me give like a 50 over here. So kind of a size it has like a changed, right? As you can see over here. So 50 bins. So dispersion wise, so small, so in between 10 to 20, now we have like a small distribution, and with the help of that, it is showing me all those like a graph. If I'm going to keep it like a 10, so and this way it is going to show you. But yeah, tendency of the data set is not going to change at all. As simple as that. Fine. So this is what a histogram is. Now let me talk about a box plot over here. Box plot. So SNS, again Seaborn SNS I'm going to use, and I'm going to call a box plot over here, and box plot will be helping you out in terms of finding out the outlier. Yeah. So on a x-axis, I'm going to say that take a total bills and then try to plot it. So here, right, here it is trying to show me interquartile range. Let me play with some colors. Color is equals to, let's suppose, orange. Okay, so this like become bit of beautiful, I would say, right? Now, so this is basically a box plot. It looks like a box plot, right? And there are some circles which I'm able to see, which is looks like an outlier to me. Yeah, which looks like an outlier to me. So now if I'll just go back in my calculation, or maybe I can try to recall those calculation here itself. So my Q1 was 13, my Q2 was 17.795, my Q3 was basically 24.12, my IQR was technically 10.77. So this is something which I was able to calculate in my last class, if you remember, right? So here my Q1 is 13 point something, my Q2 is 17 point something, my Q3 is 24 point something. So where these points will be represented, let's try to understand it with respect to the graph. So here, let me use my pen. So here, if you will try to look into this entire phenomena, like a graph that I'm trying to plot. So this is my Q1. Technically, this is my Q1. This is my Q2, which is a median of the data. And this is my Q3. This is what this line is trying to represent. And if you're going to do the comparison with the values, you will be able to find out the exact same thing. For example, so here, when I say Q1, right, what is the value of Q1? 13. So yeah, it is like a 13, right? So between 10 and then above, a little bit above, right? So if I'll talk about a Q2, so what is my Q2? 17. So yes, it looks like a 17, obviously, because lesser than like a 20. If I'll talk about a Q3, so what is my Q3, by the way? So my Q3 is 24.12. So it looks like a 24.12, as you can see, my Q3, right? And when I say interquartile range, so basically the width of this graph, this one is actually IQR. So most of my data will fall under this particular range, right? This particular range, which was nothing but a difference of Q1 and Q3. Yeah, which was a difference of Q1 and Q3. And then any data above. So what is this point? So this point is Q3 and then plus 1.5 times, means Q3 1.5 times IQR. Yes. And this was what? So Q1, this point, minus 1.5 times IQR. So any data which you will see here, so you can say that it's an outlier. Any data which you can see here, you can say as an outlier. So if someone is going to ask me a question that do we have an outlier? yes, we do have an outlier inside our data set beyond this 40. So there is an outlier. And if you remember, so we have also calculated an upper bound and lower bound. So maybe I can try to check with that what was my upper bound. So my upper bound was 40.29. And yes, this line I'm able to see, the boundary point, or this particular line I'm able to see there itself, right? That point I'm able to see. Sorry, I'm not able to draw properly, but yeah, so I'm able to see that point, 40 point something. And beyond that, it is trying to represent the outlier. Now, beyond that, if there is a data, then it will try to show you in this format, in this particular way. There is no data. So there is no outlier on a lower side or a negative side, you can say, but there is an outlier on a positive side. And even the previous graph was trying to tell me the same thing. There was an outlier, right? Even this graph is trying to tell me the same story, that there is an outlier. So this is how, guys, a graph is going to help you out in terms of finding out the outliers. It's not very difficult, I would say, but yes, it's coming from the same concept or theory that we were able to discuss and we were able to understand. It's not coming from somewhere else. It's the same story that we are trying to build it with respect to the graph, which is going to give you a visual effect by which you will be able to find out the things. So this is this box plot we are able to draw. Now let's try to draw something else over here. So SNS, and I'm going to draw a bar plot, let's suppose. Yeah, I'm going to do a bar plot over here. Now, so to do a bar plot, so x-axis is, sorry. So I have to give basically a x-axis over here. So x-axis wise, I have to give some data. Let me show you a tips data first of all. Once again, so this is my tips data, right? This is my tips data. So if I have to plot, maybe if I have to do a bar plotting over here to build some story. So bar plot, I have to give a x-axis. So let's suppose as a part of a bar plot, I would like to show you that what was average tips per day. Yeah. So my x is going to be tips data of, I can say, a day. Yeah, this is going to my x-axis. So on x-axis, a day I'm going to represent, and then y-axis I'm going to represent a magnitude. That okay. So what was the tips that people were able to get, by the way. So here y-axis is going to be tips, and here, so basically a tip value. Now if I'm going to do this like a bar plot, right? So a bar plot, I will be able to see that, okay, so the average tips which was, and here, so let me mention my estimator. So estimator is nothing but numpy dot mean. Yeah. So what was the average? It was same, by the way. So what was the average tip on Thursday, Friday, Saturday, and Sunday? So obviously on Sunday, so people was getting like a more tips as compared to some other day. Yeah, so people are getting more tips as compared to other days. So this is what it is trying to represent as a bar plot. On a x-axis, so categorical data. On y-axis, so I'm trying to represent the average of it. Now there is something called as a pie chart. So let me show you with the help of like a pie chart, a smoker distribution. Yeah, so smoker distribution I would like to show you basically with the help of pie chart. So here what I will do, so I will try to create something called as smoker underscore count, and smoker underscore count is coming from this smoker dot value count, means total number of values, value counts. So this is going to give me like a total number of values, basically total number of the rows, by the way. So total number of like a count for the smoker, no is 151 and yes is 93, right? So 151 people are non-smoker and 93 people are basically a smoker over here. Now let's try to do a plt dot pie plot over here, and let's try to pass a data. So first of all, smoker count, I'm going to pass it down over here. So this is something which I'm able to like a plot, but there is nothing like although I am able to understand that blue is representing a non-smoker and orange is representing basically a smoker, right? But I have not given a label to this one. So let's give a label to this one. Yeah, let's give a label to this one. So there is a label parameter, and label is going to be smoker count dot indexes. So here non-smoker blue is representing, and yes is been represented by smoker. And this is just showing me the distribution, and this kind of a graph is called as pie chart. Yeah, so this is basically a pie chart, and I can try to show whatever I want over here, as simple as that. Now, so let's try to plot another graph over here, so which is called as a line plot. And with the help of line plot, I would like to show you the average tip by table size. So we have a tips data inside a tips data. So we have a table size. So somewhere 2 people are sitting, somewhere 3 people are sitting, somewhere 4 people are sitting basically. So average tips based on the table size, if I have to plot, maybe I can try to use a line graph over here. So simple, call SNS dot line plot over here, and then try to pass a data. So on X axis, what I'm going to pass, so tips data of I'm going to pass a size. So SIZE. We had a tips data, right? So size. Yeah. So from tips data, I'm selecting a size column, by the way. And Y axis wise, I'm going to give a tips. So tips data, and then inside that we have a tip column. Fine. So this is something called as a line plot. You will be able to find out. So, and now just by looking into this line plot, you will be able to do some sort of a observation. Simple, right? You all will be able to do some sort of a observation that if table size is 1, a tip was like less. If table size is increasing, right? I can see the relationship over here that if table size is increasing, so even tip size is increasing over here, right? If table size is increasing, so even tip size is increasing. This is what this line is trying to talk about. Simple. So this is again another conclusion that we all are able to find out of this line plot. Now let's try to do some other plot over here, which is called as a pair plot. Yeah. So which is called as a pair plot. So let me show you this. I have prepared for you. So let me call a pair plot directly. So this is basically called as a pair plot. So where we have a total bill, I have basically passed 3 columns, total bill, tips and size. So it is going to show you a scatter plot, and it is going to show you a histogram. So histogram with respect to a data, and then data itself, and then it is going to show you even a distribution. So this is something called as pair plot, which is going to give you a lot of understanding between column to column. So for example, if I'm looking into this pair plot, so total bill and a size, right? Total bill and size. So this is the distribution of the total bill and the size, which I'm able to find out. And just by looking into this data, there is no relationship which I'm able to find out. But here, so total bill versus tips, if I'm looking into this one, so I'm able to observe something that if total bill is increasing, even my tips is increasing. Right? Even my tips is increasing. This is what I'm able to see. This is what I'm able to find out. And then this one, the histogram that you are able to see. So tips versus a tip. So basically it's for histogram for the tip column itself. So here tip is skewed on a positive side. This is what I'm able to find out just by looking into this particular plot, by the way. Now looking into this one, tip to size, there is not much of a relation I'm able to find out. Then size to size histogram. So yeah, so majority of people was in a pair of 2, by the way. This is what you will be able to find out. Then tip to, again total bill. So as my total bill is increasing, my tip is increasing, and even total bill is bit of skewed. That we have already figured it out, right? On a positive side. So on a positive side, it's been skewed. So this is the conclusion that you all will be able to draw, guys, with the help of pair plot, right? A pair plot. Now, so there is another graph. So graph wise, we have multiple graphs, but yeah, so there is another graph that I would like to show you, and which is basically a heat map. Again, so I'm trying to consider basically a correlation between a total bill tips and size, and here, so I'm just trying to call a correlation, this one, and then I'm trying to like call the heat map. So here, right? So here, let's try to understand that what is a correlation between one to another. So total bill versus size, what is the correlation? 0.6, right? Total bill versus total bill, obviously same column versus same column, it will be having a similar kind of a correlation. Total bill versus tips, what is the correlation that we have? So it's a 0.68. It's a positive correlation that we have, right? So this is what this heat map is trying to represent with the help of different color. So hope this understanding about the graph and relationship between our theory and a practical is pretty much clear. Going forward, we have a dedicated class just on a graph in a Python itself. So where we are going to talk about the graph from the various scratch. But here, so I'm just trying to show you whatever I have discussed with respect to my theoretical understanding. So with that, thank you so much everyone. Take care and see you again.